Good morning, everyone. Welcome to today's Explore Classroom event. My name is Joe Geographic from National Geographic, and I will be your host for today. If you've been following along with us all month, you know that we've taken a deep dive into extreme environments. So learning all about these areas, learning about the scientists and explorers who braved them to bring us back exciting footage, exciting research. These areas may be hard to get to, they may be hard to survive in, but we've had a blast this month talking to all kinds of scientists and explorers from all around the world. So over the next few days, we're really lucky. We're going to get to connect with a large team of explorers who just recently spent some time on Everest. So over the next little while, National Geographic is going to be running a series of expeditions looking at life at the extremes. So as part of this robust effort to improve our understanding of resilience to the impacts of climate change on mountain systems, National Geographic recently, supported by Rolex, for their first series of Perpetual Planet Extreme expeditions, returned from Everest. So we're so excited today to be joined by Mary Hubbard and Bibek Giri. We're going to learn more about why Everest rocks. So they just returned from that expedition I just mentioned. The expedition spent about 2 months on Everest, and they were able to spend a month exploring the area. So it's so great to have you both joining us today. We're excited to learn a little bit more about Everest and geology and just what it was like living at that extreme area for that period of time. So how are you both doing today?
Great. We're good. Yeah, thank you.
All right. Well, we've got a great group of classrooms joining us from across North America. We've got classrooms who are just starting to tune in with us live on YouTube. So a shout out to those classrooms. Use this chat sidebar on the right. Let us know where you're watching from and send us in some questions. But Mary, I'm going to turn things over to you and you can take over for a bit.
Okay. Well, thank you very much for this opportunity. It's really great to be able to see the classrooms that we see, and Guten Tag to those of you in Germany. So yeah, it's great to have this outreach. We were pretty lucky to have this experience that we had. Not everybody else gets this, and so we hope to be able to share as much of it as we can with you, and hope that someday you too will be an explorer and get to have experiences like this. So Bibek is my graduate student. He's a PhD student here from Nepal. He's been in the US a little over a year now, working on projects back in his home country. So the work we'll talk about today will be part of his thesis dissertation research. So I'm gonna switch us onto the PowerPoint so that we can share some images with you. We can't share the wind and the cold and the smells and the fresh air all with you, but we'll do our best with some images. So let me. Okay, how's that look?
All right, looks good. We just need to go full screen. I think we're good.
All right. Yeah, so we're going to start out here just with this picture. This is Bibek standing there for scale on the top of a little knob in the high Himalaya. And hopefully this just starts out and gives you an idea of how impressive these mountains are and how tiny we are as humans when we get up in that area. So Bibek's going to introduce the area to you and where we actually were in the Himalayas. Oops, so how do we go to the next slide? Oh, no.
You just have to click on this. There you go.
Oh, okay.
Hello, everyone. So in this slide, I'll just talk about where the Himalaya is. This is the map of the world. For those of you in the US, you can see your country, United States, and to the other side of the world is my country, Nepal, south of China, north of India, and that's where most of the Himalaya is. So the Himalaya is running sort of by this red arrow sandwich sort of between China and India. Moving to the next slide. So yeah, we just, in this slide, we'll talk about how they form. So to the image in the left, you can see because of plate tectonics, the continent of India broke up from Gondwana and then started moving north towards the Eurasian plate. And 50 million years ago, it smashed the Eurasian plate. And on the right, you can see the slices of Indian plate coming to the surface along these major fault, what we call fault or thrust surfaces. You can see those STDS, MCT, MBT. So they are the major thrusts. These are the reason why we have really big earthquakes. And this is the reason why we have these huge mountains or high or tall mountains. So you can see Mount Everest is above that purple sort of a polygon, and that polygon is the higher Himalaya. So Mount Everest is kind of in the higher Himalaya.
And we should mention that this collision continues today. So India, as we speak, is still inching closer to China. And so that's why we hear about big earthquakes still in the Himalaya.
The last one being 2015 Gorkha earthquake, 7.8 magnitude, destroyed a lot of homes, including mine.
Yeah.
This is Google Earth image of Himalayan mountains. I really love this image. Here you can see that arc-shaped shape of the Himalayan mountains. Off to the south is China or Tibet, brownish sort of region with a lot of lakes. And then to the south is India, really flat lying plain. You can see the color difference between Tibet being brown and India being red. All these
Green.
major, green. All these major rivers draining into the Bay of Bengal. To the south, yeah, this shown by the red arrow is where Mount Everest is. We call it Sagarmatha. That's how I call it. And folks from Tibet or China call it Chomolungma.
Great. Okay, so we're interested in how mountains are shaped, and we go into the mountains to try to learn the history about how they formed and what's happening to them today. But really, there's two big processes that shape mountain belts, and one is faulting. And so the two images on the left-hand side show the collision zone between India and Asia, and then faults such as the one shown in the block model that move pieces of the earth upward with respect to the other side. And so that's how we get mountains built up. And again, that's an active process in the Himalayas today. We still have faulting that is increasing elevations of the mountain belt. But at the same time that we're pushing the mountain belts up, we're tearing the mountains down. And the active agents for tearing mountains down are river systems and glaciers. So the two images show both of those. And in the Himalaya, we have active glaciers. So what's shown here in this one photo with the little blue lakes is something called the Ngozumba Glacier. And it's in the valley where we were working right beside Everest. And you can see a couple little people in that photograph. So again, it gives you a sense of scale. But these glaciers are melting rapidly, and they melt in the summer months anyway. And the rivers that come out from the glaciers actively carve out the valleys, and they erode material and carry material down and out to the oceans. So landslides contribute to this, but landslides will drop material, rock material into the river valleys, and then the rivers act to carry that material, to break it down and carry it outward. You want to talk about rocks? Okay. Okay, so there's lots of different rock types in the Himalayas, so it's really a great place to work. We have a few rocks with us, which when we change screens, we can show you a little more closely. But we have granite. Granite is a rock that formed from melt, and the photograph on the far left is Bibek standing actually at a little spring of water. The reason I took this photo was because there was water coming right out of a crack in the rock. And all the prayer flags there denote that the local people find this a sacred place, a place they can get very pure water coming right out of the granite rock. So his hand is on the granite slope. In the middle, that photograph is a river deposit. And so there, the rivers have just left very recently. And so in the last thousands of years, rather than millions of years, they've deposited gravel and sand. And so you see some very big coarse pieces up at the top, up high in the photo, and then finer grain things coming down to sand layers across this old river deposit. And then the far right, the little yellowed spots are the tents at Everest Base Camp. So that's where the climbers camp before they go up that big glacier and up to the summit of Mount Everest. Up at the top of the photo, you'll see some horizontal layers in the rock. And so the top of Everest is actually sedimentary rock. It was once on the seafloor. It has some small fossils in it that give us an indication of the age of those rocks. So that tells you that rocks went from 0 elevation, from sea level, all the way up to 29,000 feet, maybe even higher, but now they've been brought down to this level. But we have metamorphic rocks that are rocks that have evidence of being buried and subjected to high heat and temperature. We have the sedimentary layers from the ocean floor, and then the igneous rocks were melts and magmas that moved up through these rocks when they were buried down deep. So on this expedition, our research was focusing on the impact of climate. And we're trying to learn about that climate record from the sediment, the rock layers, the rock material layers that have been deposited by ancient and modern glacial lakes. So on the left-hand side, you'll see Bibek with 2 other Nepali students working to sample a sand layer that we hope to get an age on. So that's in process right now in the laboratory, but of a very ancient glacial lake. So the lake was up high, higher than we have lake levels today. And we want to understand when those glaciers were there. On the right-hand side is a modern glacial lake near a village called Gokyo. And we did not sample on this particular lake. You can see it's covered by ice. But we sampled 2 other lakes that were just down the valley, maybe a half mile or so from this photograph. And so in the next picture, you'll see us in the next slide. Here we have some images of what we did on the modern lakes. So to collect samples on the modern lake, we have to go out on these rafts, and we take a device, and the device is lying across between the 2 rafts on that photo. It may be a little hard to see, but we drop it down between the 2 rafts, and it's connected by a rope. So we hold on tight to the rope. Actually, the rope's tied to the boat. And we drop it down to the bottom of the lake. So that photograph on the far right-hand side is a picture of the lake bottom, just taken with my cell phone that happened to have a waterproof case on it. And we were in a shallow part of the lake when we sampled there. So you could actually see the apparatus on the bottom. And there's a little weight that's kind of a cylinder that's tied to a separate rope. It's tied to the white rope in that photo. And we can pull that white rope up and bring that weight up about 6 or 8 inches and then drop it. And we do that again and again and again, and it slowly hammers our coring device, which is a big plexiglass tube that, again, you may be able to see stretched across the boat in the middle photograph. But we do that until we've collected about 1 meter of sediment inside that plexiglass tube, and then we pull it back up to the surface. And so the photograph on the far left-hand side shows our research team. We were 6 people. So myself, I'm holding one of the core, and the other professor from Nepal is holding the other core. And then we have these 4 students with us. So we were successful in 2 different lakes getting core. We actually collected 2 core from each lake. One stayed with the students in Nepal, and one we have here in the US to do some analyses. Go ahead. And so we bring those core back to the lab. And on the far left-hand side, that photograph is the little saw that's used to cut the core in half. So we cut the plastic on the edge. So there's a little saw that spins, and it cuts just through the plastic edge so that we can then run a wire down through the core and separate it into 2 pieces and basically open it up. And when we open it up, we get an image like the 2 core that you see photographed in the middle. One of them has a big sort of a Z-shaped fold in the middle, which is quite interesting. And that probably formed from an underwater slump or slide of some of the sediment on the slope of the maybe somewhat steep lake bed within the lake as the lake went to deeper water level. But we bring these back into the lab once they're opened up. We scan them and get some information from different analytical instruments that scan them. It measures the density, measures grain size. measures its magnetic properties, and then we sample them. So on the far right-hand side, you see the Nepali professor, Professor Gajarel, was sampling to pull out some pieces of sediment from which we'll get ages. And then also we will examine them for tiny little fossils that we see inside those core. And so just to wrap up, I hope that gave you a little bit of a taste with some images, but the mountains, it's taken millions of years to form these mountains. Remember I said that collision it happened about 55 million years ago, or started, and then the process has been an ongoing convergence. And that's first buried rocks down deep to where some of them melted or were changed through metamorphosis. And then they've been brought to the surface along faults. And then the valleys have been carved out so we can really see inside those mountains. And it's our job as geologists to then unravel that history and try to understand something about the rocks and the history from the record that we see. So we'll take the slide off so that we can see you.
All right, welcome back.
Yeah, thanks.
Very cool. Well, Mary and Bibek, thank you so much for sharing that with us today. It looks like an amazing place, some amazing pictures, and most importantly, some good science got done. And that's always exciting. So I'm sure you'll be working on those results for some time to come and taking a look at those samples and such.
Yeah.
All right. Well, we need to meet some of our classrooms, but before we do, I want to give a shout out to some of our YouTube classrooms because they've started introducing themselves. So we've got a group of grade 6-7 students at the French International School of Philadelphia. We've got another class hanging out in Lynchburg, Virginia. We've got some Canadian classrooms, one grade 5 classroom hanging out in Ottawa, another middle school classroom hanging out with us in Hoover, Alabama. So great to see the classrooms joining us. And yeah, don't forget to send in some questions. I'll keep an eye out for them as they come in. Any other classrooms watching, feel free to introduce yourselves as well. Let's get to some of our live classrooms. So as mentioned, we have a classroom joining us all the way from Germany today with some students hanging out, Mr. Flores' group. Let me get their microphone turned on and let's see how they're doing today. Here we go. How are we doing, boys and girls?
Good. What you?
Hey, I have a question. How many hours did it take to climb up that mountain?
Ah, wow, that's a very good question. We didn't go to the top of the mountain, but we did go up into that valley, and it took us about 4 days walking. And part of the problem is that the elevation is so high and there's less oxygen. So we hike for maybe 5 to 7 hours during the day, and then we spend the night so that our bodies can adjust to the increase in elevation. Then the next day we climb another 5 to 7 hours. So we're walking on trails and going through villages. So it takes a long time.
And did you find after a little while that your bodies did start to adjust nicely for you?
Yeah, it was really great.
Yeah, very cool. Well, that's a lot of hiking to get to that spot. But students, if you take a look at that area, take a look at a map after our event, you will see that it is sparsely populated and it is quite a trek just to get to the base camp of Everest alone before you start something like a climb. So very cool. Let's jump to another live classroom. This time we're going to visit, let's see, Mrs. Hunter's group. They're hanging out with us in Canada. Let me find their microphone and get it turned on. How are we doing, boys and girls?
Good. We're good. Hi.
Oh, nice.
All right, awesome. Who's got a question for our geologists?
I have a question. You guys said there was fossils up at the top. So what kind of fossils did you guys find?
Ooh, yeah. So the fossils there are microfossils. I don't actually know the species. That's not the research I do.
Crinoids.
There's what?
Crinoids.
Oh, crinoids. Yeah. So I think Ordovician in age, if you know your geologic time scale. So the rocks that are on the top of Everest, they're oriented at an angle that dips down onto the Tibetan side. And so a lot of the great work that's been done on those sequences of rocks from a sort of paleontologic point of view has been done in the Tibetan area and in rocks and outcrops there.
Yeah, and I think that's one of the really cool things about, when mountains form like that with that collision of plates, when things that at one stage were below sea level are now pushed thousands of meters above the ground, and you're finding fossils of sea creatures from millions of years ago at those high elevations. It's pretty wild. You really can see how our Earth changes and how extreme our planet is. Very cool. All right, let's see. Let's take a little trip to Texas. We've got Mrs. Elliott's class hanging out with us. Looks like a mixture of students from grade 6 to 8. So let's get their microphone turned on. There it is. How are we doing, boys and girls?
Oh, wow.
Where did y'all sleep and what did y'all eat?
No, can you come a little closer? I didn't catch that one. Or louder.
Where did y'all sleep and what did you eat?
Where did you sleep?
Yeah, where did That's a good question. So where did we sleep and what did we eat? Do you want to answer? Or?
Yep. So along those trails, we have these small places we call tea houses. So like when Mary was talking about acclimatizing, we were sleeping in those, except for in the base camp where you need to sleep in a tent because there are no tea houses there. So yep, we slept in tea houses. We slept in the tent in the base camp. And for what we eat is you can have plenty of choices, most of them Nepali food, but you can have some pizzas if you want, some cold drinks, almost a different sort of food. So your choice. You don't have to eat if you don't like it.
Well, you have to eat because you need the energy. There was one photo of the lake and there were some buildings behind it. Do you remember that picture? So that was the little village of Gokyo, and we slept, those were all tea houses that were there. So they're kind of like small hotels. So we slept in those and they have kitchens and cook meals for you. And like Bibek said, you can order a pizza if you want. It might not be quite the same as the pizzeria that's down the road from you, but it tastes pretty good when you're up at that high. But also lots of Nepali food, vegetables, rice, potatoes. We drink a lot of tea.
All right, so probably quite a bit different than some other members of the team who are staying, say, at base camp. They probably had a much more rudimentary.
So surprisingly not. They did sleep in tents, but have a beautiful kitchen staff. Now the kitchen staff is cooking in a tent, but I think the night we arrived in base camp, they served us lasagna. That was pretty impressive.
Very cool. Well, I've got a great question from online. I'm going to give a shout out to a couple more groups. We have Mrs. Deer's class joining us from Chesapeake, Virginia. Mrs. Farrell's class is joining us as well. But I do want to put this question up here. This is a good one. They're wondering if we could fast forward time in that area, what would we see happening with Everest? Is it rising, sinking? What's going on in that area?
Wow,
That's a really good
great question. If that student could please apply to our graduate program, we would love to have you. No, that's a great question. And a lot of the work we do on climate is in an effort to address that, because as climate changes, it has a very big impact on communities, on the people that live in the area and the people that live downstream. So one of the fears, of course, with warming in the area, and it's very visible, actually you can sort of see it happening, is the melting of the glaciers. And so as we move forward, likely we're going to lose those big glaciers. And the question is how that impacts water supply downstream, because downstream Nepal and into India, it's all very agricultural, depends on water, and people need water anyway. But as we lose these big reservoirs in the ice storage that the glaciers provide, we don't know what will happen in the future. Everest, we can monitor now with GPS, we can monitor ground movements. And so we have tools that we didn't used to have in the past. We do know that we get uplift of the high peaks in the Himalaya, so they are actively going up, yet like I mentioned, they're eroding at the same time. And so trying to track that balance of uplift and erosion. But as long as India continues to converge towards China, we're likely to have this continual interplay of uplift and erosion. If that were to cease, then we end up with erosion dominating. And a few of you probably live pretty close to the Appalachian Mountains. And the Appalachian Mountains were also a collisional mountain belt, but this collision has stopped long, long ago. And so then the mountains erode down, and what you end up with are kind of rolling hills, like you've seen if you've been into the hills of Virginia, Pennsylvania, up into New England, and so on.
All right, great question from online, and we'll duck back to YouTube shortly, but let's go back to another live classroom. So we're gonna go to Windsor, Ontario here in Canada. We've got some, looks like a STEM geography class hanging out with Mr. Jaro. Let me see if I can get their microphone turned on. There it is. How we doing, boys and girls?
Where are they?
Oh, I think you have to get really nice and close for us. The sound's really low. Mr. Chitter, if you can take a quick check on your computer. We had your sound when you came in, but it's not going now. If you look next to the mute button on the left, there's a little arrow there. If you click on it, you might be able to switch between your microphone options, and that might reactivate it for us.
Is that better?
Yep, we got you.
Okay, so I was just wondering how you determine the safest path to take. Like, do you improvise or is it planned beforehand when you're climbing up the mountain?
Okay, so I can relay that question. So she's wondering, when you're going out, you're looking for samples, you're collecting things. These are areas that are shifting and changing. How do you determine a safe path to take? Do you plan ahead of time? Do you kind of look around you while you're there? How do you kind of plan the areas you're going into?
You want to answer?
Yeah, sure. Yeah, I think the answer would be good planning and improvisation. So you plan ahead of time things you're going to do, probably some samples you collect, but conditions are changing, like you said. So, and we improvise. If the conditions are changing, then we improvise and adapt to that changing conditions. But we do plan ahead of time.
So because people live in that area, there are trails that go from village to village. So a lot of what we do is utilize the trail system. But when we want to go off trail, that's when we definitely pay attention to safety conditions. We don't want to be under a cliff where there's rock fall, or under a glacier where there may be avalanches.
Or walking on the ice.
Or
we
yeah,
want to do that.
Yeah.
All right, awesome. Great question from our group in Windsor. We need to go to Mrs. Sullivan's group. They're hanging out with us in Vermont. Looks like some 3rd and 4th graders. Let me get that microphone turned on. How are we doing today, Vermont? All right. Nice and loud for us.
Did you guys train it all for the Did you guys train it all for just the hike up?
Was that question, did you guys have to do training before they went?
Yeah.
Yeah? Okay, very cool.
Yeah, so we did. Actually, we are appreciative to National Geographic, who signed us up for sort of an online training program. Now, this wasn't a human being that came and got us out of bed in the morning and made us go run on the track, but it was an online system where we could log in and keep track of the workouts that we did and watch how it was going through the winter. And we live here in Montana, so my training consisted a lot of cross-country skiing. We can just 10 minutes from the university campus, we can put on cross-country skis and work out. And so since we left for the trip in April and we had a long winter last year, a lot of that skiing for me, or a lot of that training could be on skis. And Bibek, I see Bibek at the gym. What was your favorite training?
Mine was ping pong and racquetball.
Ping pong and racquetball.
All right, fair enough. Well, you got to be quick in ping pong and racquetball. Yeah, you got to move quickly. So you're activating those muscles. Very cool. Let's take a quick trip back to YouTube and snag another question. Okay, so this question here, we've got the classroom wondering, this is our group, Miss Farrell's group in Calgary, Alberta. So they're probably used to mountains. They've got some in their backyard. They're wondering, from what you've looked at so far, has anything surprised you so far from maybe the samples you've collected or something on the expedition? Any results surprised you so far?
Yeah, that's a good question. We're really just at the early stages of getting analyses done. But I'll say the biggest surprise for me was when we opened up that one core and found that there was a big set of folded layers in the middle of the core. And so trying to understand if that was caused from the shaking due to an earthquake or, like I said, sort of an underwater landslide of sedimentary layers or what it was. We have just sent samples out to get some ages on them. And we sampled the layer just below the folding and the layer just above the folding so that we hope to be able to kind of get some idea of when that event might have happened. But that was one of the early surprises. Otherwise, we're still in process looking at the fossils that are in the core and getting ages on the ancient lakes. So that process for those ancient lakes that we sampled, the process takes about 9 months. So it'll still going to be 6 months before we have those results back. Oops.
Out of curiosity, because this question comes up often when we talk to paleontologists and other people, archaeologists who are working and aging things, what method are you using to age the samples?
Yeah, that's good. So there are two methods. For those ancient lakes, we use something called optically stimulated luminescence. And that basically looks at quartz grains, and the quartz grain structure at the microscopic level, the crystalline structure gets damaged from radiation that comes from radioactive elements that are in minerals surrounding the quartz. And but that damage is sensitive to light. And so when that quartz grain is exposed to sunlight, the damage is healed. And so when you have a sand grain that comes down a river and gets deposited on a riverbank, it doesn't have that damage. But as soon as it's buried by other layers, over time, the damage to the structure accumulates. So the optically stimulated luminescence can measure that, and it's calibrated so that you can then calculate the time. The core samples we've sent for radiocarbon. So that's looking at carbon-14. And so there has to be some organic material with carbon in it to get those ages.
All right, very cool. So carbon dating. So just to help some of the classrooms out there, Mary, so basically, you know that carbon, the element, it decays at a steady rate. It breaks down at a steady rate. So that's what you're using to measure how much it's broken down.
Right.
All right, very cool. We need to take another trip. We need to visit our group that's joining us in Illinois. Mrs. Rhodes, looks like some 7th graders. Let me get their microphone turned on. Where is it? There it is. How we doing, Illinois?
Good morning. Don't worry, guys. There you go.
So, how big do you think Mount Everest could get over time?
I think, yeah. So we're not very sure, but the way to think about it, I think it's the tallest as it can ever get or it ever did. I think there's a limit on how tall it can grow because of glaciers tearing it down and how fast you're actually growing them. It might have been taller slightly, but not very high. So this is, I think we are kind of at the limit of how tall mountains on Earth can be.
Okay, so there might be fluctuating of say inches or so, but we're not going to get like much higher than this kind of 8,000 meter that we have, kind of 14 peaks that have kind of passed 8,000 meters on the planet.
Right. And honestly, we don't know in the past how, whether mountains have ever been higher than 9,000 meters, and we won't know for the future either. But
yeah, well, that's the thing with geology and what you're working with is you see snapshots of billions of years. So it is hard to look back and see exactly what things might have been like further in the past.
Right.
All right, very cool. So we have a little bit more time left, so I'm going to visit a few more of our live classrooms. So if you have a burning question in your classroom, let me see some hands, or send someone nice front and center to the camera, and that'll be a good signal to me that we need to visit your classroom again. So I think I see someone with their hand up, our group in Germany. So let me get their microphone turned on. There you go, nice in front. We're ready for you.
Hi, my name is Noah. I'm wondering, since you guys, like, where did you guys sleep? Like, I know where you guys slept, but how come you didn't get oxygen deprived or something? Like, how come your oxygen didn't go down that fast when you guys were sleeping?
Yeah, so we control that a little bit by not climbing too high from one night to the next night. So the elevation that we gain each day when we hike is not so much that our bodies can't adjust. And the highest we went for our geology research was just to that Everest base camp. There will be other scientists on later this week that went higher on the mountain, and then it gets much trickier. But again, they climb, they gain enough elevation that their bodies can adjust ideally overnight. But the people who go highest on the mountain actually take oxygen tanks with them, and they breathe oxygen so that they're helping their bodies that way. We didn't have to do that because we climbed smaller amounts each day. And then your body actually, while you're sleeping, your body does some of the adjustment. It modifies the chemistry in your blood to allow it to take in more oxygen than it does when you're down at sea level.
All right, we're going to go back to Windsor. I can see someone standing in a nice white polo for us. Let's get that microphone on. We're ready for you. Mr. Turo, whatever you did with the microphone, can you do it again? It seems to have switched off on us again.
I was wondering what physical or mental struggles the explorers go through while climbing the mountain.
Okay, so Mary, I don't know if you can speak to this a little bit. They're wondering about some of the physical and mental struggles that maybe you had to overcome, or maybe others on the expedition. Maybe you heard some stories about when you visited base camp and such.
Yeah. Do you want to say what was your biggest challenge, Bibek?
Well, for me, I had a cramp in my leg when we were hiking down. So that was like biggest physical struggle for me, with walking down with a cramped foot. And there were some mental challenges as well, preparing for the next day, coming back from work, and then thinking about what's going to happen next day. So those are sort of the mental challenges, planning the work itself.
And for me, I think that one of the biggest challenges is staying healthy. I ended up with a cold and lost my voice when we were up coring the lakes. And so, it was just a health thing, and it's a little harder for the body to recover when you're at that elevation. But otherwise, our group stayed pretty healthy. The other students that we had were from Kathmandu, so they were Nepali students. And I think they hadn't been maybe away from home or out in such a harsh environment for such a long period of time before. So I know that they were very ready to get back when our time was up. Their pace markedly quickened when we were headed downhill.
All right, Illinois, patiently raising his hand. Let me get that microphone turned on. There we go.
All right, go ahead, Brody.
Oh.
On Mount Everest, how high up can life like birds or other animals exist until it gets too cold for them to either breathe or just live?
Good question. You want to address
Yeah, the biology team that was also in the expedition recorded caddisflies. It's an insect that was at 6,200 meters. So I think that is the elevation record for the highest insect. In generally speaking, trees, you don't really have a lot of trees after 3,000 meters or above 3,000 meters, and you don't really have any bushes or grass after 5,000 meters. So that's what we call the nival and subnival zones. So the tree line and the herb-line or plant lifeline. So yeah.
But there are sort of mountain goats up there, and there's some mountain birds like sort of grouse and pheasant type birds that live up pretty high, so between 4,000 and 5,000 meters.
Okay, so obviously life at that extreme, we lose some of the biodiversity. We lose certain species at different heights, but 6,000 meters, that's pretty impressive for an insect species. That's pretty cool. It'd be neat to study their adaptations for that lifestyle. All right, Texas, Mrs. Elliott's group, your microphone.
What equipment did you bring and how did you get it there?
Microphone was a little loud there, but they asked about the equipment you brought and how you got it there.
Okay. Oh, well, we'll show you a few of the things. So the rafts that you saw and the coring equipment, we had porters that we hired. So these were people who would carry sort of a duffel bag. They carry it kind of like a backpack, only using usually a strap across the forehead. So the rafts and the coring device were carried by them, as was a lot of our own living gear. But the things we use on a daily basis when we're looking at the rocks, we have a compass, but the compass can also measure, it's got little level bubbles in it, and it can measure the angles that rock layers are tilted. And so we keep track of that when we map out the rock layers. Of course, to collect a rock sample, you have to have a hammer. But before you decide which one you want to collect, you may want to use a hand lens and look up very closely. So we do have some rocks here, and we can look at what the minerals are inside the rocks. And then when we've sampled things, we have to have a way to bring the samples back. So this is just a canvas sample bag that we would put a rock sample in. But the core, we had, we actually carried 2 big ski bags. So if you all are familiar, if some of you are skiers and have gone skiing and have a bag that you put your skis in when you travel to the ski mountain, that's what we use to keep the core samples, to put those core samples and the coring equipment and tubes in, because it's very long and skinny. And then the porters had to carry that gear up the mountain for us. And then, Bibek actually has with him here some of the clothing. So of course it's quite cold up on the mountain, and I would just go ahead and do your jacket maybe, and your hat. And so a typical day on the mountain, we'll show Bibek here. He's putting on his heavy jacket, and then the hat that was typical to see Bibek in, and he might have even been wearing it on the boat in that photo, I don't remember. But there you see him with his jacket and hat to stay warm.
All right, very cool. Thanks for modeling that gear for us. As always tends to happen here, time goes really, really fast. I want to do a huge shout out to our classrooms who joined us both on YouTube today as well as on camera. Thank you so much for hanging out with us, for the great questions. If you did take any pictures today, post them to Twitter with the hashtag #ExplorerClassroom, tag at @NatGeoEducation, because we love to see pictures of classrooms in action. And Bibek and Mary, thank you so much for hanging out with us today, for sharing what it was like to spend some time collecting samples on Everest.
All right, well, thank you all, and great to see you all, you students, and we'll see you at the university someday soon.
All right, I'm going to unmute all the microphones, boys and girls. A big goodbye and thank you. Then we'll sign off for today. Here we go.
Bye.
All right. Thanks again, everyone, for spending some time with us. We've got another event coming up at 1 Eastern where we'll talk more about the expedition in general, and then another one at 3 o'clock today where we will talk about Glacier. So we hope to see some more classrooms joining us live. So thanks again, everyone, and we'll see you next time on Explorer Classroom.